Good morning, everyone. This is Mr. Shields back again with another video here. Today, we're going to be talking about systems of linear inequalities here. But before I go ahead and dive right into the lesson, I want you to make sure that you've gone ahead and done lesson 9 before then. So if you remember, we went over various notes about how to graph linear inequalities. In that lesson, we just had the one inequality that we were graphing, and then, of course, there were the different steps to help you determine what kind of line it would be, whether or not it's solid or dotted, and then whether or not you would be shading up or whether or not you would be shading down. So you're really going to want to make sure you've learned that lesson here, because I'm going to be teaching this lesson with the assumption that you're already familiar with and comfortable doing that. So let's dive right into this lesson here. I said there are two inequalities this time when we're dealing with systems of linear inequalities here. And then the area in which it overlaps, where those two inequalities are going to be overlapping, is going to be the answer or the solution set to these problems here. So let's go ahead and graph the very first problem up here. So we have y is greater than negative x minus 1. So my m is going to be a negative 1. And then my b is also going to be a negative 1. So I'm going to begin with the b. Go ahead and put my dot here. And then that negative 1 is going to tell me I got to go down and then to the right one. So I'm going to have a lot of little dots on this particular inequality here. Now, just as a side note, I will include a blank copy of these graphs, so feel free to go ahead and print this out. If for some reason that you don't have that, that's fine, because in the second part of this video, I'm actually going to show you guys a little bit of a shortcut, which I think will make your lives a little bit easier. Yes, it does involve Desmos, so hopefully that'll be helpful to you. All right, so in the meantime here, with this graph, since it was a greater than sign, that told me two things. One, I'm going to have a dashed line. And also, since it's greater than, I'm going to be shading upward. Okay. Now, with my second inequality here, my b is going to be negative 5, and I'm going to have a 1 as my slope. So I'm going to go ahead and graph that. I'm going to use a different color because I think it'll make things a little bit easier for you to see here on screen. At least hopefully it does. All right, and then the 1 over 1. So I'm also going to have a lot of dots going on here. So bear with me as I put those dots together. Now, since this is a less than symbol, I'm also going to have some dashes here. So we can go ahead and, if I can get my ruler positioned the right way here, excuse me, I'm trying to use this on my clipboard. And I have my dash line here. Not very neat, but oh well, very effective all the same, I think. It says less than, so I'm going to go ahead and shade down with that blue. Now, hopefully, with my graph, you're able to see that there's a part on my graph, very small part here, where the orange and the blue overlap. And I'm going to put a big old S right here. And that S is for solution. So any point that is in this little triangular area here that I'm pointing out to you would be a potential solution. So for instance, maybe, I don't know, what, 7, negative 1, or maybe an 8, 1 up here. Those would be potential solutions here. All right, so that's all we're doing with that. I'm going to skip on to number 3 here, because I want to show you a couple where you have to solve for y. You notice the first one was nicely set up for us, but in the second one here, I have that very first inequality that I'm going to have to actually set up and solve for y. So I'm going to go ahead and rewrite it down here, deal with that first thing. And so when I do that to solve for y, like I mentioned in the last video, I'm going to go ahead and take that x, subtract it out. So I'm going to have a negative 4y less than or equal to negative x plus 24. And then I need to get y all by itself, so I'm going to have to take that negative 4 and then divide. But of course, when I'm dividing by a negative, that's going to change that symbol. So instead of less than or equal to, we're going to have greater than or equal to. Negative divided by negative, so I'm going to have 1/4 x, and I'm going to have minus 6. So this is what I can graph here, in addition to that bottom equation here. All right, so let's go ahead and start with our orange inequality, I should say, not equation. So let's graph this here. So -6 is going to be my y-intercept. So it's going down 4, 5, 6. And then that +1/4, so that tells me I'm going to go up 1 and to the right 4. Up 1 to the right 4, and then up 1 to the right 4, and then I have to go the opposite direction here, making sure I'm getting those points just right here. And since there is a line under the sign, that tells me this is going to be a solid line here. If I can get this out of the way, don't have too much space here, so bear with me. And then my blue inequality. Oh, let me go ahead and throw my shade first, getting ahead of myself. So that's a greater than sign, so let me go ahead and shade up. Okay. And now I'm gonna go on to my blue inequality, and I'll notice that my y-intercept is 1. So I'm gonna go ahead and put my blue dot here. And you can always do your shading after you've done with both inequalities. Sometimes that's easier, sometimes maybe it's more confusing. It's entirely up to you. I'm sorry, not my y-intercept, but my slope is a +2. So that tells me I'm gonna go up 2 over 1, up 2 over 1, and up 2 over 1. And I'm gonna go the opposite direction. And so one advantage to actually waiting to throw your shade is you don't have to deal with those lines or that shading getting in your way, as you can see here. Now, that also has a line under the sign, so that's going to be a solid line here. So as I take a look here, I have that solid blue line, but since it says less than, I'm going to be shading downward with my blue. Now, as I shade down with my blue here, hopefully you guys are able to see where there's going to be some overlap here. And so I'm going to have a little overlap in this particular area right here. And that overlap, we can put a big old S right here, because that's where our solutions are. So for instance, 1, 1 would be a solution, or 1, -4 would be a solution here. All right, let's do one more manually before we get into our shortcut here. So if I take a look at number 4 on this side here, I have an x is less than -4. So hopefully it comes to mind with the VUX, right? So when x is by itself here, I'm gonna have a vertical line at -4. 1, 2, 3, 4. And since it's a less than sign, that's going to tell me 2 things. One, it's going to be a dashed line here. So let's just go ahead, do my dash. And then, of course, it's going to also tell me which way I'm going to be throwing my shade here. Since it's less than, I'm going to actually be going to the left. So any number less than -4. So that'll be a little bit different than the other 2 inequalities where we were shading down if it was less than. So let's go ahead and take a look at my other equation. This one, I'm going to actually have to solve for y first in order to make sure it's in slope-intercept form. So I'm going to subtract my 3x. So I have 2y less than or equal to -3x minus 2. And then I'm going to go ahead and divide by 2. And we'll have a -1 here. And so that -1 is going to be my y-intercept. So I'll put my dot here. And that -2 is going to tell me I have to go down, sorry, -3 is going to tell me I have to go down 3 and then to the right 2. Down 3 and then to the right 2. And of course, I'm going to have to go the opposite direction. Up 3 over 2, up 3 over 2, and up 3 over 2. And since I have a line under the sign, I'm going to have a solid line here. And so I'm going to go ahead and draw that line out here for you guys. And so we can throw some shade now. Since it says less than or equal to, I'm going to be shading down. Now, hopefully you can see that area where the blue and the orange come together, and that is going to be my set of solutions here. So this part right here would be where my S would go. Now, as I mentioned earlier, don't worry if you don't have graph paper or you don't have a printer, you can't print out this blank sheet. Um, Keep in mind, there is a second way of doing these problems, and it is using Desmos. They will also give you probably a nicer graph than what I did here, but we're gonna do problems 5 and 6 in the second part of the video. All right, so we're back here with the second part of the video here. So I showed you manually how to do this, and as you can probably guess, Desmos, I think, does it a little bit clearer, or at least it has better graphs. So I'm gonna go ahead and look at number 5 here, and I already took the time to write it into Desmos here. And so I have that inequality. I'll try to move this to the side, I'm trying to share my screen with you guys here. And so if I take a look, I've written the inequalities. And if you notice, the good thing about Desmos, I don't actually have to solve for y here like I did in the previous 2 examples. And so you'll see here that I have purple for one of my inequalities here. I want to say that's the second one here. And it's also very color coded, so you can see the purple here and the light purple here. Same thing here with the green. You see the green, or light green, I should say here. But where they overlap, this space right here, that's our solution set. Now, what would be a potential solution? Well, I can actually check some points here. I can actually do 10 and let's say 2. And you'll see that red dot appear. Well, that's a potential solution. But what if I did -10 and let's see, +2, for instance? That would not be a solution because it's not in that shaded or overlapped area here. All right. And so let's go ahead and type one in on real time so you can see how that will look. So I'm going to do number 6 here down below, just as a reference here. So let me go ahead and type that in. I have 6x plus 4y greater than, and so I'm going to have to move this a little bit over to the corner so I can get those symbols here. So we'll have greater than 12. And then my second inequality, I'm going to have a 3x minus 4y greater than 8. So let me slide this over here. And so once again, you'll see that this dark green area where the blue and where the green kind of merge together is going to be my solution set here. And so what will I do? I can always check points. And you're not really going to have to do this for the IXL that you're going to have, but I'll explain that in just a second. So if I take a look at the 7, -2, well, there's a potential solution. But I could have also said, I don't know, let's say 10, -4. All right, so that's also in the area. And you can also rule out points. So I know looking at this, what, -6 and 4 wouldn't work, would not work, I should say. And so there we go, that would not be a solution. So the good thing about Desmos, you don't have to go ahead and solve for y. As long as you type in everything correctly, you should be pretty good to go. So what you're going to have to do with your IXL that I'm going to assign is you're going to actually have to be able to graph them on IXL, and it's going to be looking for that shaded area. So one thing that you could do is you could have Desmos on one tab here, and then you can open up another tab and then go ahead and do your IXLs and just kind of go back and forth with. So I wanted to show you both ways, by hand and also using Desmos. It's your choice as to which you're going to use in order to go ahead and solve these problems here. But wanted to give you those options here. So that concludes lesson 10. And so I'll see you guys all in the next video. Bye.